Kia ora. Here's one of the complex numbers questions from this year's Pure 3 paper. So this is a really old one. This was from the 2010 paper. I think it's paper 31. The first two parts in here are good for calculus complex numbers. There's a locus problem in the second part. I just want to comment quickly on the difference between doing that for A-level and doing it for complex numbers. As I've said, if you're in class with me, when you're doing this for A-level, it's fine to just do it using geometry and from recognizing what each of these sets of points will look like. If you're doing that for level 3 calculus, from what I understand of the marking schedules, you need to show your substitution. So you should start there by letting z equal x plus iy, right? And then working through the algebra. Now, you don't need to do that for A-level, so I'm not going to do that in this video, but just be careful, watch out for that. Check with your teacher and see if they agree. They might not. All right, so we're given a complex number. It's a very easy one. It's 2 plus 2i, and that is denoted by u. We have to find the modulus and the argument of u. We don't need to show a whole lot of working for that. We can do it pretty simply with a little diagram. So here is 2 plus 2i, mod of u, or we can write it as in the usual way like that, is just going to equal 2 squared plus 2 squared square rooted, so it is Pythagoras, right? So that's root 8. And then the argument of u, we can see straight away from looking that I'm going out to and up to, so arg of u is equal to pi on 4. By this point in the year, that should feel very, very easy. Right, let's now look at the next one. We have to sketch an argon diagram showing the points representing the complex numbers 1, I, and u. So it's important that we label our axes and do all the basic stuff well, or we're going to just chuck marks away. It's also going to make it harder to solve this part of the problem if we don't have a decent graph. And then we have to shade in the region whose points represent the complex numbers that satisfy both of these inequalities. So let's look at what we've got here. This was done extremely well by the class. So this pattern here is saying in words, distance, I'll just turn off the ink to shape, distance, so that's what the modulus signs mean in common sense English, the distance between my point z and the point 1 plus 0i, so this point here, is less than or equal to the distance between z and 0 plus I. And if you're practicing for Pure 3, you will have done tons and tons of these, and that should feel pretty easy. And we know that what we're looking for here is, here's the first point, here's 0 plus I, the second point, here's the first point at 1, and so we're going to start by saying let's find the set of points that are equidistant. So the first point that we know will be on there is the midpoint of the 2 points. And then we're going to be looking for the perpendicular bisector of the little line segment here. So there's my line segment there. I'm going to take my ruler and I'm going to whoosh through a perpendicular bisector. Sorry about the music, guys, but I live in a house with normal people. Okay, so that graph is not good enough, I don't think, because we haven't labelled stuff. We haven't said where u is. So we're going to move now to a slightly bigger and better graph that's drawn to scale. Oh, but first, let's look at the second part. So this bit here is saying that we want this. The distance between z and my point u, which is 2 plus 2i, has to be less than or equal to 1. So that's describing a circle with a centre at 2 plus 2i and a radius of 1. So I'm going to move on to another slide now, and we're going to draw all of that out nicely. So the first thing to do is we're going to mark on the 2 points. We're going to mark on I, which we'll put here. We're going to mark on 1, which we'll put here. This is 2, and this is 3. This is 2i here. Those yellow dots are just to help me with the scale. I did those before I made the video. Right, so let's do the perpendicular bisector first. We can see that it's going to have, well, I'm going to go a little bit slowly on this in case anyone's not all good with it. So we've got those 2 points there that we're joining up. The perpendicular bisector of those 2 points is going to go through here, and it's going to go at an angle of 45 degrees. Now, hopefully this is to scale enough to make that all work. Right, so there we go. That's going to be the perpendicular bisector, and we just want to shade in one side. So let's happily delete that little line now. And we'll also delete the yellow dots. Oh, no, we're not going to delete the yellow dots. Bad. This is why technology is painful. There we are. Let's put everything back in without me putting the video on hold. Right, so let's do this again. We know that the perpendicular bisector is going to come through that point there. Now, you can't take in a ruler that's that good, but you can take in a compass and a protractor if you want. So here's I here, and here's 1 here. Now, my circle is at 2 plus 2i, and it's got a radius of 1. So we can dot those points out. I'm going to draw this freehand because that's what you're going to have to do in the exam. Okay, so it looks a bit like that. So it's a little bit wobbly. Now we want the points. We want the points that are closer to 1 than to I. So that means that we want to be on the lower side of the perpendicular bisector. Now, importantly, that perpendicular bisector goes through that center point there. So these are the points that we want. The last part of the question is the most interesting. Oh, also, I need to label that that is U. This is the point 1, and this is the point I. This is the real axis, and this is the imaginary part of the axis. Okay, let's just go back and read what we have to do, because this was badly done. We have to find the value of the modulus of z for the point in the region for which arg z is the least. Now, lots of you decided that there had to be this point down here at 2 plus I, but that's not what's going to be the lowest angle, right? So take your ruler and remember why we get the point of tangency on that circle that's joining up a point on the circle with the origin. So I'll draw that line in. Here it comes here. So what we need to find is the length of this line. I'll call that point big A. This point can be O, and this point can be X. Some of you will see this straight away. We know that the tangent is perpendicular to the radius. That gives me a right angle here. And we're looking for length OA. Well, by Pythagoras, we know that this side is 1. And we know that this distance here is root 8 from the first part of the question. So using Pythagoras, we get the square root of root 8 squared, so 8 minus 1 squared. So my answer is the square root of 7. So there you go. That's that problem done. I think that is a reasonably easy complex numbers question. The second part, or the third part, is quite straightforward because we just had one triangle in here, right? So that pink triangle that we've got there is just one example of finding a length using Pythagoras. In some more complicated problems, what you're going to have to do instead is you might have this triangle in here, and you might also have a triangle here. And you might need to use your compound angle results from trig to do something a little bit more interesting, but that's not this question. Thanks for watching. I'm going to do the differential equation question next.